Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Q Learning and Policy Gradients. Your first steps into RL algorithms. Imagine teaching a dog new tricks. You don't give it a manual. You give treats for good behavior and maybe a gentle no for bad. That's reinforcement learning. RL. In a nutshell for AI. Our AI agent learns to make decisions by trying things out in an environment and getting rewards or penalties. It's like building an AI that can play a game, drive a car, or even manage complex systems, all by learning from experience. As developers, we're building these intelligent agents that can figure things out on their own, rather than being explicitly programmed for every scenario. Every RL problem has a few key players, like characters in a story. Agent. This is our AI program. The brain making decisions. Environment. This is the world the agent lives in and interacts with, e.g., a game board, a virtual car track. State. A snapshot of the environment at any given time, e.g., current position of pieces on a chessboard. Car's speed and location. Action. A move the agent can make, e.g., move a chess piece, turn the steering wheel. Reward. A feedback signal from the environment after an action. Positive for good actions, negative for bad, e.g., winning a game, crashing the car. Our goal as developers is to program the agent to pick actions that maximize its total future. Rewards. Like programming a game character to explore and earn points. Imagine you're playing a new video game. Instead of figuring everything out, what if you had a cheat sheet that told you, for every possible situation, state, and every possible move, action, how good that move would be? That's the core idea behind Q learning. It tries to create a giant table, called a Q table, where Q stands for quality. Each entry in this table tells our AI agent the expected future reward for taking a specific action in a specific state. As developers, we're essentially programming our AI to fill out this ultimate strategy guide through trial and error, learning the quality of each action. Our AI agent starts with an empty or random Q table. It then explores the environment, learning as it goes. 1. Observe state, sees where it is. 2. Take action, picks an action, sometimes randomly to explore new options, sometimes the best one known so far to exploit its knowledge. 3. Get reward a new state, receives feedback and sees the new situation. 4. Update Q table. This is the magic. The agent uses a simple formula. Think of it as averaging past experiences with new ones, to update the quality value in its Q table for the state action pair it just experienced. It learns that if an action leads to a good outcome, that action's Q value increases over time. By repeating this process thousands or millions of times, the Q table gets more and more accurate, guiding the AI to optimal decisions. For a developer, this is an iterative algorithm where we define the update rule and let the computer run it until the values stabilize. Q learning is great for simple games or environments with a limited, manageable number of states and actions. But what if your game board has billions of possible configurations? Or if your agent is driving a car where the state includes speed, position, angle, other cars' positions, an effectively infinite number of possibilities? The Q table would become impossibly huge, too big to store in memory and too slow to learn. This is where Q learning hits a wall. We need a different approach when the world our AI lives in is vast and complex, where memorizing every single scenario isn't feasible. Instead of building a giant cheat sheet, Q table, what if our AI could learn a skill directly? Imagine learning to ride a bike. You don't memorize every possible body angle and pedal pressure. You learn a policy, a general strategy or instinct that tells you how to act given the current situation. Policy gradients do exactly this. Our AI learns a policy directly, which is a set of rules or a brain, often a neural network, that takes the current state as input and outputs the best action to take. It's about optimizing the asterisk way the AI makes decisions, rather than memorizing the value of each decision. With policy gradients, our policy is typically represented by a neural network, which acts as the agent's brain. 1. Observe state. The neural network takes the current state as input. 2. Take action. The neural network outputs an action, or probabilities for different actions. 3. Get reward. The environment provides feedback. 4. Adjust the brain. Here's the key. If the action led to a good outcome, we slightly adjust the neural network, its internal weights and biases, to make that action more likely in similar situations in the future. If it was a bad outcome, we adjust it to make that action less likely. This adjustment process uses a concept called gradients, like finding the steepest path in calculus to climb towards better performance. Over many trials, the neural network learns an effective policy, much like how a human learns a skill through practice and feedback. As developers, we're training this neural network, providing it with experiences and using optimization algorithms to refine its decision-making ability. So, when do you use which? Q-learning. Best for environments with a small, discrete number of states and actions, e.g., simple board games like tic-tac-toe, classic control problems. It's simpler to understand and implement initially. Think of it as explicit memorization. Policy gradients. Essential for complex environments with continuous states or actions, e.g., robotics, self-driving cars, complex video games. It can generalize to unseen states and handle high-dimensional input. Think of it as learning a general skill. Both are fundamental stepping stones in reinforcement learning, teaching our AI agents to learn from experience and make intelligent decisions in dynamic worlds. Understanding these helps you choose the right approach for your AI challenges. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.